Okay, so now we're on to slightly more mathematical ways of writing our vectors using position and displacement vectors. So your position vector, and again, you should have read a little bit about this in the booklet before doing this, hopefully. Position vector from O to A is a vector that takes us from the origin, so in this case it'd be 0, 0, to the point A. Okay, so the vector that goes from there to there. Obviously, because it is a vector, it doesn't have to be in that specific place, but that is its kind of main general thought process. So if you've got a point 3, negative 1, which obviously won't be as this diagram suggests, it would be more down here, the vector will just be 3, negative 1, but as a vector instead of as a coordinate. So is the vector required to get from the origin to that point? Obviously it can be placed anywhere, so it's a vector, but generally speaking that's what its main intention is. Similarly, O to B will be 5, 0, like that. Now vector position vector is incredibly important, and understanding how to use these and understanding how this works. So when we do displacement vector is really, really important. Okay. So if we want displacement vector A to B, what we can say is that A to B can be written as, and we need to make up of two vectors we already have. And you can use lots of different methods, and you can use diagrams really successfully for this, but I think the easiest way is look at the vector you've got, assume that you can swap them round, so OA you can also get AO. And therefore we can make this journey up of A to O plus somewhere which is O to B. So A to B with a middle step in the middle. So the middle step is going through the point O effectively, or this journey. A to O, then O to B. So we have OA, but we can swap it to AO quite easily. And then we have AB. So really easy if you can understand this little journey and how vectors work in this way. Notice, because it is a vector, either position vector somewhere to somewhere, I'm using the arrow above, so I'm not using the bold or the underline. This is more what you see generally speaking for vectors. So if O to A was a journey 3 across to the right and down 1, A to O will be 3 to the left and 1 up, or basically just swapping the signs is what it entails. So 3, negative 1, negative 3, 1. OB is still the same. So overall, again, get used to writing this stuff out properly in vector notation. A to B will be 2 and 1. They will look at your notation when you do vectors. It's quite clearly talked about in the teacher guidance. They want you to use proper vector notation. Right, part B. Find the position vector of C. Okay, so we want O to C, that means. The position vector means find the vector O to C. So we've now got CA as well. Now, because we're ending at C, we're not going to be using CA. We're probably going to be using A to C, because we need to end at C. So we now need a vector which gets us from O to A, otherwise known as OA. So it's just kind of piecing together what you've got, finding that middle step, and then getting what you need. So that means O to C will now be 3, negative 1, plus, so if this is CA, so it's I then J, so it's in the correct order, so it's now going to be positive 4 and negative 2. So that means O to C as a position vector will be 7 and negative 3. Okay, nice and straightforward.